You found SSH running on a workstation, but here is the mistake. You saw the -r and you thought this is just a tunnel, but this can be a SOX proxy. In this demo, you will see the attacker flow, then the defender view. In the defender view, you will be seeing the process view and the follow on network activity. That prove SSH is used as a pivot to an internal network. This is the next part of the series for defending against ransomware. Let's start. So in the previous part, we have already covered the discovery commands, adaptive C2 and some of the NL test, net and whoami discovery commands. So just to give an overview of what is the infection chain of this attack. So this report is from DFIR. So user was searching for a manage engine op manager and through SEO poisoning campaign, user landed on the malicious website. Then it downloaded the trojanized software for manage engine and then he executed on the system. So the malware was executed on the system and it also dropped the Bumblebee malware. I will highly recommend to watch the previous video or read about this attack. So it's quite detailed and quite good. Let's come back. So this is the attack flow which I have created. We'll not be going through all of them in this video. We'll concentrate on this command and control part, where attacker has established a SSH tunnel to an external server. Now we understand the attack flow. Let's move on to the lab diagram. So this is my lab which I will be using for this demo. To keep it simple, I will be using only 3 machines: desktop HR, which is a compromised host, domain controller, and this is the attacker C2 server, which is running on the cloud, and the SSH port is on 3333. Apart from that, there is Elastic Stack running on my system, and desktop HR has a Elastic agent, PowerShell logs are forwarded, and Sysmon logs are also forwarded. Then I have also installed Microsoft Defender Endpoint on this desktop HR. So this is our compromise host and this is our attacker machine and this is our ELK stack running with the Sigma rules. So now we'll move on to the compromise host. So this host is already compromised. Now attacker will run. So our attacker will be running this command on the compromise host. So what does the command do? It's using -r star. So when it mentions star, it means it's binding to all the interface on the remote machine, and 10400 is the port which will be open on the remote C2 server, and -p is the port number for SSH. In this case, attacker is running on 3333 port number for SSH. So if you don't specify a destination, SSH treated as a SOC proxy. This is also called as reversed dynamic forwarding mode. So after running this command, there is a SSH tunnel established between the attacker and the compromised host. So whenever someone connect to 1040 port, so whenever someone connects to this port, it will redirect the traffic to this one. And a SOC proxy is running on the server. Anything executed from this port will be executed inside. Let's jump on our desktop HR compromise host. So this is my Windows 11 machine running on VMware workstation, and this host is already compromised. This is our desktop HR machine where attacker will be running the SSH command. So I have already created a index.html. So nothing much, just saying hello from the desktop HR compromise host. Let me start a Python server on this host. Let me copy. So Python is only running on the local host. It's not binded to all the interface. Now let's open one more CMD. I should have used the terminal, but yes, anyways, let's go. So in this one, we will run our SSH command, which we discuss here. So this is my attacker machine, which is already set up on the cloud. Just to show you what ports are listening: L, N for numeric, T for TCP, and P for process name. So as you can see, only 53 port is open, and it's listening on 3333, our SSH port. So desktop HR machine has a Elastic agent, and it also has a MD installed on the system. Let me show you the Elastic. I've already opened. There is no alerts. Looks good, and this is the Defender. This is a desktop. Currently, there is no alerts. All looks good. So all looks good. Let's go back to our desktop HR. So the web server is already running on desktop HR machine. Let us check this one. It's all good or not. Yeah, so this one is working. Now let's execute the SSH remote tunnel command on this desktop HR host. Yeah. So we have copied the command. So this is my username, and this is the cloud server which is I am running, and using -r star binding to all the interface, and this is the port number which will be open on remote. That's why this is called as a remote tunneling, and this is my SSH port number. Let's execute this command. Okay, now we have logged into SSH, and we have executed that -r command. Let me go back to my attacker machine. Then see, so now 10400 port is already open on the attacker machine, which is running a SOC proxy. So we are running this curl command using this SOC proxy, which we have just opened 10400, and so we are trying to access this website. Let's go back here and press enter. See, now this content is coming from our compromise host. So attacker is using the SOC proxy, connecting to this port and executing this command. So here also you can see the same thing. Let's go to the Elastic Stack. So this is the Sigma rule which is fired when we run this command on desktop HR. So you can see the command. So you can see the process tree, command.exe running the .exe. Here again you can see the same process argument. So our Sigma role is firing correctly. This can create some false positive also, but we will see how to investigate this kind of alert. So we'll learn how to distinguish this one if this is a false positive or a true positive. But if you see the command carefully, you can see it's trying to connect to the remote IP. And so this looks definitely suspicious. Before moving on to the Defender portal, this is the Sigma rule which is firing. So I have already opened this Sigma rule. Let me zoom it little bit. So this is a Sigma rule which detect the port forwarding activity via ssh.exe. So the category is process creation and the product is Windows. So it's just checking if image ends with ssh.exe and command line contains -r. So there is expected false positive. Admin activity using a remote port forwarding to a local port. But in our case, it's not forwarding to local port. It's opening a SOC proxy. Suppose you want to convert this rule to KQL, which is used in Microsoft Defender Endpoint. You can use Sigma converter, or you can use the detection studio. Okay, I have already selected the KQL, and one pipeline I have already selected Microsoft XDR. So this is the query which is generated by this tool using py sigma. So this is the final KQL query generated from this Sigma rule. Let's copy paste and execute in our advanced hunting. So you can use this query for hunting, which is generated by Sigma converter. So you can see the folder paths in with ssh.exe and command line contains any one of them. In our case, is matching ssh.exe and command line contains -r. So this is the device process uh, events table, and we can see the ssh.exe running with our. Let me copy a modified version of this query. So this is query is very similar to the previous one, but I have modified little bit. I'm using file name instead of folder path and just using project as reordered for the important columns. Let me execute command line. So you can see the same process created ssh.exe, and this is the command line executed, and this is the initiating process. Now let's go back to our attacker machine and we will try to create some network traffic. We'll perform some network activity which will create some entries in device network events using our SOC proxy. Let's try this one. So I've already set up the proxy chain on this machine. Let me show you the config once. Okay, if you go down, you can see I've already added the SOC proxy with this port number. So if I run any command using proxy chain on this machine, using SSH tunnel, it will forward that traffic to desktop HR, and this compromised host will execute that command. In my case, I'm just doing a simple curl to check if proxy chain is working. As you can see, this command is working fine. So it's connecting to this port number 10400 and connecting to Microsoft.com. Let me clear the screen. So now attacker can run any command using this proxy. Let's come back to our desktop HR. Let me stop the web server. Not needed. So let me ping the domain controller just to show if it's up or not. 92.137. So as you can see, my domain controller is up. Let me try to ping from the attacker machine. You should not be able to, but let's try. As expected, you cannot ping it. So for the demo purpose, let me run the nmap command on my domain controller. I just wanted to generate some traffic so it's visible in the network event table. Okay, so we are running the nmap command and it's scanning this IP. You can see it started, so it's scanning all the ports 139, 445, 995. Let's see if any other alert fire on using Sigma. I don't expect, but let's see. So yeah, only one alert Sigma port forwarding activity, and this one is also one. Now let's move on to some interesting stuff. So now you know the process is running. Now we want to correlate this activity with the network events. That's why I've executed the curl and the nmap command on desktop HR using the SOC proxy. We can use this query and go 1 hour should be good enough. So again, we are just querying the device network event table, initiating process, file name SSH, and command line contains -r. Let me do reorder data project. Remove this timestamp. So you can see there is Microsoft.com, which was accessed using the curl command, but you cannot see the curl command executed because it is executing inside this tunnel. So that's the main thing to understand. But you can see the network activity. In our case, we have already executed the nmap. Let's see how it's going. Let me stop this nmap traffic, otherwise our network event table will be lots of hits. Control C. We can see the SSH command running on this machine. So what can attacker do next? So attacker will normally use some lateral movement or will want to connect from this machine to some other machine. In our case, we executed the nmap on our domain controller. So let's see the network activity, what's going on. As expected, there are 68 items. Go to full screen. So you can see this is the curl microsoft.com which we tried in our which the attacker tried. And here you can see there are multiple connection failed and success event. So this is why this is happening, because nmap is running and the attacker is trying to scan the domain controller. But as you can see, the initiating process is still SSH. You cannot see any nmap or anything in your command line because all those things is coming from SSH tunnel. That's why this is not visible. But still, if you combine the process activity with the network event, you can see what's going on. So just to recap what we did. So attacker executed this command on the desktop HR machine. This is the machine. And after executing the command, attacker can connect to this machine using SSH. After that, we executed the curl command using SOX proxy for Microsoft.com. And then we also executed the nmap to scan the network to generate some network traffic. Coming back to our Elastic Stack, we can see one of the Sigma rule fire related to this activity, port forwarding activity via ssh.exe. So you can implement this Sigma rule in your environment, but it may cause false positive. So you have to filter those false positive, and then you can identify the pre-ransomware activities. So in the device, in the advanced hunting in MDE, we executed the device process event query. You can see there is only one command line related to SSH, which contains -r. But now we want to correlate the process event with the device network event. So device network event contain the initiating process file name. Maybe in this case, you are thinking this may be a false positive. But if you use the correlation between process and network events, you can definitely see this is not a false positive. This is a true positive. An attacker is trying to do suspicious on the network. Let me do full screen. 99 items increased. You can see this is our remote IP, and this is our domain controller. You can see the name. So the nmap is executing on desktop HR. So the attacker is executing nmap using SOC proxy. That's why you can see the local IP as desktop HR and the remote IP as a domain controller. So there are multiple ports and multiple connection failed and success because nmap is trying to scan that domain controller. Let's go here. Here you can see the parent process, some version info, and some more info from the device network table. I will not go into that detail. What we can learn from this video is that correlation between process events and network events, and it can be any SIM, it can be MD, it can be CrowdStrike, it can be Elastic. But so the main concept is to understand the attack and how as a defender we can defend. I hope you like the video. See you next time. Thank you.